All right. Hello, everyone. Welcome to Kubernetes SIG Auth biweekly for April 3rd. Let me pull up the agenda here. So we have a fairly sparse agenda today, but let's jump right into the discussion topics. Greg, if you're on the call, I think you have the first.
Yeah. So, did Matt join as well? Matt, are you here?
Yeah, I'm here. I'm just in a public area because
you're super quiet. Yeah. So this kind of so there's a short doc here that I wrote, and this kind of came out of the discussion that Matt started about Knative and their API, and they're kind of in this position where they're trying to figure out if they should allow people to use secrets and environment variables, similar to how Kubernetes currently does. If you're starting workloads through Knative, like, is this a security practice we want to allow or disallow or kind of discourage? I think are sort of the options. So I kind of wrote down some things that I thought about the decision to do it inside Kubernetes. I kind of wish we'd made it a bit harder inside Kubernetes than it currently is. So it's the original rationale, which I think is like perfectly valid, is that well, maybe I should start with why not. So there's a link there. I think a blog that Diogo wrote at some point about kind of all the scary things that can happen if you start putting secrets in environment variables. It's pretty common for people want to dump those out in their environment, and they get persisted in unexpected places, people trying to debug things. And so there's some pretty good reasons kind of not to do it, but there's also some very good reasons to do it. So if you're running software where you don't control how the software consumes secrets and or API keys or whatever it happens to be, and it does it through environment variables, you don't really have many options. Like if you can't change that software and you need to run it, then you kind of need to give it an API key or whatever it wants in an environment variable. So kind of the argument I was making here is that it would have been nice if we in Kubernetes had some way to like signal that like this is the bad practice, and to like kind of put some pressure on people doing that kind of thing and hopefully eventually discourage it. As it is now, it's kind of just part of the API, and even though kind of in the original issue we said, oh, we should discourage this in the docs, we don't actually discourage it in the docs. So I think from the Kubernetes perspective, the first thing we should probably do, like assuming the audience here agrees that with the approach, is we should actually discourage it in the docs. That we should kind of point out to people the ways that this can cause them problems. And we should, and CJ linked, and I think I linked in the doc like a couple of examples where we're kind of actively doing this in documentation. So we're not really sending the signal at all that you maybe don't want to do this. So I think that part is kind of fairly easy.
Greg, I was going to actually add here, like it doesn't just have to be the docs, but the API documentation as well. I mean, one of the advantages of, because we do this, people who are using this, you know exactly who's using it. And that was actually one of the discussion points originally, was we wanted to bring workloads to Kube. We realized that like everything on Heroku does this, right? And so there was a certain amount of like the art in the industry, but at least you know that it's happening when you're not encouraging someone to write their own mechanism that they're going to get worse. So.
Yeah, I think that's a good point. Updating the API docs to also discourage it would be great. Any other comments on kind of that piece of it? I think like that's the easy part. Like that's not much work.
Yeah, I mean, updating API docs, updating our examples to not use this, and in the places where we have to show it to like explain how the API works, like just sweeping and putting warning. Like, you shouldn't do this unless the software you're running this way, unless it's the only option. Like it has these downsides. It makes sense to me.
There's some bigger conversations around pod security policy that need to happen, but that aside, is this something that would make sense to add to pod security policy?
Yeah, that was kind of my next point in that doc there, is that if you if you kind of assume that like you're an organization and you want to beat down this behavior because you see risk in this behavior, and then you kind of like, if you can get yourself to a clean state where like it's not happening anymore, you sort of want to be able to shut the door on it. And so like have some enforcement mechanism that said, all right, I cleaned up my environment. Only like the things that absolutely have to do this are currently doing it. Everything else I cleaned up. How can I like prevent people from falling into this trap again?
Well, and that might even...
Policy, that seems like
it doesn't
kind of
sound like
a different...
Jinx.
Arbitrary back off. Okay. That seems like a change in pod security policy's mission. Like its primary mission is to protect nodes from pod spec authoring users. This seems like it's kind of straying into like, we're going to encourage you to make pods that follow best practices. And so if we reject this, like the alternative is, well, I guess I'll just hard code the password into an environment variable value of my pod if you're not going to let me pull it out of a secret. Like,
I was actually going to ask, like, so there's a certain element though that Jordan, like there are lots of organizations that don't have a strict rule that you must run as non-root, but they would like to begin moving in that direction, right? So imagine the current Kubernetes world where pod security policy isn't on by default. Our discussions about how do we move people in that direction. There's going to be a lot of, just like with RBAC, there's going to be a lot of warning and auditing. Is there an element of PSP that is a warning mode where we could actually put a profile in non-enforcing mode and actually return real messages to a human versus a giant bundled ball of goop that no human understands except maybe David?
I think that even if we chose to do that, I don't think this would fit underneath that, right? Like the pod security policy is about find a way to protect, to prevent users from leveraging pieces of the system that they shouldn't, that can actually be dangerous for tenancy reasons. And this isn't related to that.
I was going to maybe ask though, like, so Jordan had the example of like, okay, well, fine, I'll go load it myself into the environment. We have not talked about this in a long while, but there is an argument for pod security, and maybe it doesn't have, like, we're over fixating on pod security policy. Let's invent a word that is execution security policy, which says you shouldn't run bash as your entry point, or you're allowed to run this entry point, where some of these things could be enforced. So like some of the Knative and other frameworks might actually have an entry point that does the right thing here. Maybe they're like, passes it in by a file descriptor or something like that. Is there something analogous to PSP that is actually about best practice enforcement that overlaps with security?
I mean, that seems a lot more like best practice linting, like customize my policy for my organization and decide whether I want to hard fail or warn, or like that seems like more of the extensible like OPA style things where I'm going to define a set of rules, like pods in my organization may use bash or may not use bash or must use bash or whatever the policy is. That seems like it would be really unlikely to be a single agreed on definition that would be like a baked in policy object.
Yeah, I mean, certainly accessing volume types, like volume type was about security, but I have seen it used organizationally as well. Not in a ton of places, but it is something that overlaps. Like, where does pod security policy start, and where does OPA sort of stop and start? Because like OPA is certainly a generic tool. Is there something that we should do to make it easy for someone to build an enforcer or a warner like this that fits in between? And then have someone go build one and say like, yeah, if you want to prevent this, just run this in your environment. It's a custom webhook, etc.
That's what the some of the folks working on Gatekeeper are working on. It's this idea of you have so Gatekeeper sort of has these OPA policies that you write through config maps and load and enforce at admission. But then there's this idea of a constraint policy, which basically gives you a CRD representing a template for a policy. And then that policy gets compiled into Rego and loaded into OPA that way. We should probably get someone from that community who can give an update in SIG Auth.
Yeah, knowing what capabilities that had and how hard or easy it would be for people to drop that into an environment, and how hard or easy it would be for them to share like kind of pre-baked policies for things like this would be useful.
Yeah, the other thing I was thinking too, like if you want to get into this, so like if you're in bad state and want to get to good state, it's kind of hard to do this at cluster level too. It needs to be like probably at namespace level, like, all right, this software we can't change, it runs in that namespace, it's allowed to have secret environment variables. Everything else is like clean and built by us and is not allowed to have them.
Is that a way to segue to saying that pod security policy should be namespace specific? I mean, so it is interesting too, like this does feel like above, it is enforcing best practices, which like the way that Jordan and you both articulated it does sound like it is something that should be added to the platform. It is not part of the platform, certainly in the vein of like us trying to own less and enable better extension. Like it feels very heavy-handed for us to go after one particular use in the project versus having a perfectly good mechanism for auditing new resources created. And then the gap, Greg, as you're noting, is that how do you go step by step? And pod security policy has this very problem. We could not turn it on blanket today on any cluster in the world and expect it to work first time. And so is there maybe there's something specific we could do as a best practice about how we roll that out that informs the policy group?
Yeah, I think that argument makes sense that, you know, we don't necessarily need to solve this in Kubernetes. And we can look at alternatives like Gatekeeper and solve it outside. But I think that is fairly sensible.
It's obviously a topic that we need to have a discussion about in and of itself. Can we wrap up the secret specific discussion rather than the general pod security discussion? Pod security policy discussion. So on secrets, it sounds like.
Is this really quiet for anyone else?
Yeah, I can barely hear whoever.
Yeah, who was just talking? You're super, super quiet.
Oh, this is Maya. Can you hear me?
Hey, Maya, I kind of thought it was you, but you were.
You also show up as screen name on everything.
Oh, yeah, sorry. That was because it said enter a screen name, and I entered screen name. All I was saying was this discussion is a discussion in and of itself about pod security policy, and I feel like we can have. There's a whole other debate to be had there. Just on the secrets piece, though, it sounds like there isn't a lot of disagreement. Is that correct? Can we come to agreement on the secrets piece?
I think we agree it's not ideal. We can't forbid it in tree, like it's part of the API, and it's necessary in some cases. So we agree it's not ideal. We should update documentation, update examples, make sure that people who are using it, to the extent that we can control, know that it's not ideal. The question is, do we go beyond that in any way in tree? And I'm not sure how we would do that.
So I think there's a second part, right, which is part of what prompted this, which is for things building on top of Kube that, aren't locked into this decision.
You're also super quiet. I can barely hear
you. Can you hear me now?
Bit better.
Okay. I will try and talk loudly. So the question is for Knative, which I think prompted this discussion in terms of whether we should allow this in our API, whether we, since we don't have the API compatibility requirement, whether we should allow this at all or basically bias towards a different default behavior, since we have ways of potentially disabling this behavior by default out of the gate. And so that's sort of the other half of this question.
So it is funny, I actually would ask, like, does Lambda allow this? And if it does the same argument that we made in Cube about Heroku apply, which is history gets written by the winners, and those who create systems that are perfectly secure also create systems that no one uses. And like, can we discourage without prohibiting? And if we prohibit, are we explicitly turning off a set of use cases that would be more secure running on the platform than off the platform, et cetera? Like those were like three of the arguments we made originally. I feel like they're general regardless of what. And that's like, they are a general statement of, is it better to be open tent and warn and control or is it better to exclude?
It seems like the spectrum on the one end would be, nope, enable it and don't complain about it or say that it's bad. On the other end of the spectrum is forbid it and don't support it at all. And then like in the middle, you could do things like, we'll support it, but in order to use it, you have to like set a field that's named insecure environment variable from secret or something like that. Like do better than Kubernetes did, where people can use this feature without actually knowing that it's insecure in some ways.
Although the number of times, so Kubernetes insecure skip TLS verify, we tried to make that as scary as possible and people still regularly do that and then ask if it's secure. So I think the floor is very low for expecting.
I think that's okay though, right? Like,
yeah,
because like it'll get on some auditor's checklist. It'll get in like the CIS benchmark, and like every company that actually cares about security will know that like that flag is bad, obviously. And so
the grep the code base for the word insecure and reject check will fail.
Yeah, so there will be pressure on that to remove the need for that flag for anyone who really cares about security. So yeah, I'm in favor of small hurdles that make it obvious, but like have easy ways to back out. I don't know what that means for your API, Matt. I have no idea. But if there is the opportunity for something like that, I would go for something like that.
It is a shame that we couldn't force all, historically, this is something we didn't suggest, but if we had forced your environment variable to have the word token or secret in it for it to work, when you inject the secret, that might have actually, like, we could have picked a set and said, no, we will actually reject this unless it says token or secret. So there's a well-known set of environment variables you could at least filter on. That might have been a little bit closer to the line of what you're pointing out, like insecure skip TLS verify. When people write filtering for environment variables today, what are the grep things they're going to use on environment variables? Token, password, et cetera.
If you're trying to make this work with random legacy software anyway.
Well, it was kind of picking like token. I bet you I could probably guess that 97% of secrets on Heroku that have a secret in them have the word token, password, or maybe cred in their environment variable name. It's possible that we could have done something along those lines. Key, yeah.
Clayton, I liked your point about checking out what Lambda does. I think that's a piece of Matt's decision. Figure out where that is and then decide whether to outlaw altogether or allow but strongly suggest.
Allow it, but make them feel bad about themselves. That's what we want.
It is funny, after suggesting that, I'm kind of tempted to write an admission webhook that fails unless it says token, secret, key, or password. Maybe not put it like, have it as
Don't
something.
do that to me, Clayton.
Not to you, David. It would be an optional webhook plugin, but like
We
as
wouldn't run it ourselves, obviously.
Obviously, but yeah, something along those lines. Like at least making. I mean, naming matters, as Greg pointed out. So.
Matt, has this discussion given you meaningful information and perspective?
Sounds a lot like our discussions, actually.
Wouldn't you know that they're good?
Yeah, I mean, I think the notion that you want to be able to be compatible with the workloads that exist today is one that's really valuable. And it's probably the biggest reason why we did this in Q however many years ago. And so if you can collect a broader user base by having this like Cube does, it seems like a good idea.
Yeah, that's my own feeling on this subject too. Matt, I think that kind of leaves me feeling like we have the question of, to what extent do we want to put hurdles in front of the use of this in Knative API? But that's a group discussion, just my own opinion there.
Yeah, thanks for all of the information.
All right, sounds like we should move on to the next topic, unless anyone has some last words on this. All right, so next up is something I put on here, actually kind of related to the policy discussions we were just having. So for a bit of background for anyone who doesn't know what Runtime Class is, it's a beta feature as of 1.14 for selecting different runtimes to run a pod with. And so this is targeting sandbox style runtimes like gvisor and Kata containers, but we're also planning on using it for Windows container support, and kind of thinking a little more broadly as well for weird new runtimes that no one's thought of yet. And so the way it works is you have this runtime class resource, cluster scoped resource that you declare that sort of represents the runtime to run with. And then within the pod, you just reference a runtime class, and the kubelet takes care of the rest. So when this feature was first proposed, one of the ideas we discussed was the idea of kind of supported features by the runtime. So as we move away from native Linux run C containers, there's a bunch of stuff in the pod spec that just doesn't apply to those other runtimes. So for instance, obviously if you're running with Windows containers, there's a ton of Linux specific stuff in there. And so wouldn't it be nice if there was a way in the runtime class to say, here's all the optional features that my runtime does or does not support. And then that would let us fail fast in admission or something and say, give a nice kind of user experience of, we can't run this pod as you've requested because you're trying to use these features the runtime doesn't support. So that's sort of the background on this. But one of my big concerns with this is the idea of an optional or supported feature is not well defined. And is there any way to sort of implement this functionality without just ending up duplicating essentially pod security policy embedded within a runtime class? And then we don't necessarily want users to create the privileged runtime class and the restricted runtime class in place of using pod security policies. And would some other policy mechanism, maybe pod security policy, be a better approach to defining which features are supported by a specific runtime? So that's sort of the background, and I wanted to see if anyone in this community had more thoughts on that.
I'm trying to understand the distinction between a runtime class supporting a feature and a particular user being allowed to use a feature. Like one's a statement of support, like a particular runtime either does or does not support, privileged containers or some, running with a particular UID. But that's different than is this user or this namespace or this service account or whatever allowed to use that.
Now, doesn't runtime class though modify the meaning of privileged or of some of the security implications of those? And so a certain runtime class applies a different, like it might be like gvisor, might be acceptable to run you at 0 in gvisor as long as you had SE Linux enabled, whereas you would not be able to run that without gvisor. From protecting the node, like gvisor protects the node just like running without SE Linux protects the node.
Yeah, so there's sort of a separate piece, which is I have a work in progress PR to add runtime class selection to pod security policy, because I think it is important to be able to express that, you must run as non-root, you're allowed to run as root if you are running with gvisor. So that there's kind of the security, like what are you allowed to do piece of it. And yeah, there's this sort of like weird, we get into this weird gray area between like what is a limitation of what you're allowed to do and what is a supported feature. A good example of that is there's nothing about gvisor's architecture that prevents you from running with host network namespaces. It would be pretty easy for the runtime to enable that, and they explicitly don't because it's dangerous and would kind of compromise their security model. And so there's kind of a question there of, well, should that decision be baked into the runtime that there is no way to run gvisor in insecure mode, or should that be sort of a policy piece?
This feels like a little bit of like the CAP overlap. Like CapNet admin is dangerous because you can follow the rabbit hole, and eventually, the odds that you can use it to escalate are high. And so CAP is on PSP because it's the closest tool we have to say, that. But it doesn't mean that everybody's going to set up their CAPs correctly, and that in reality, and maybe this gets back a little bit to the previous discussion, like the reality of it is given a choice between not running a workload, changing a workload, or allowing it, the vast majority of time people will choose to allow it, which might be an argument for while the runtime class could inform what the PSP should mean, it's still probably best to let the PSP be maximally orthogonal to the choice of runtime class. Like in the sense of, if PSP and runtime class collude under the covers, do we actually benefit from an end user perspective by doing that? Is the job of runtime class to protect the node, or is the job of pod security policy to protect the node?
There was a conversation about Windows pods in particular, about wanting to find a way to fail fast, or if users were creating Windows pods and requesting Linux features that the Windows runtime couldn't support. Like, it's misleading to the user for the Windows runtime to be like, yep, totally, I'm running that thing with UID whatever and group ID whatever, but not really. And so I wonder if, like for compatibility, if things that we currently ignore, like if you run a pod that has SE Linux fields set in an AppArmor environment, AppArmor is like, I don't know what that SE Linux thing is, I'm just going to ignore it. And so we can't change that behavior. But
there is, I think it's worth calling out that there's some inconsistency there, though, because actually if you try and run, if you request AppArmor in an SE Linux environment, the pod will fail saying, can't run this with AppArmor.
Oh, really?
Yeah. This is a SE Linux versus AppArmor, which is more secure argument. I wonder, I mean, the runtime capabilities is actually a pretty big part. Like pod security policy is one of the few areas where we specifically handled both defaulting and validation and constraint selection. And we haven't, scheduling does a little bit of it. It's up to I don't want to get into a debate about how useful the more complex scheduling features are, how approachable. Is there something that's analogous, which is there's a runtime class admission control validation that handles these orthogonally from pod security policy?
So we are planning on adding a runtime class admission controller. The two use cases right now are for injecting pod overhead. Pod overhead is a sort of work in progress discussion as to how exactly that will work. But the other piece is scheduling, injecting tolerations into the pod. Both of those are open keps right now, so nothing final.
I mean, certainly there are hard scheduling rules on Windows and probably on virtualization based. Like, I think it's reasonable to say that the odds of a homogeneous environment with Windows are 0, and the odds of a homogeneous environment with virtualization are higher, but not 100%. So there's a reasonable case that runtime class informs scheduling, just like it might inform allowed fields on pods.
Right.
Oh, go ahead.
Oh, sorry. We are planning on adding the scheduling support in 115. So there is a cap open for that.
Something I don't have a good sense for is how likely it is for people to write pods that target multiple runtime classes. Like, we've talked about portability types of things where people write kind of a minimal pod spec and expect to be able to target that at most clusters, arbitrary clusters, and then have things specific to that cluster kind of get added on the way in. So things like default storage class for PVCs and default priority class for pods. Default runtime class, are we planning on doing that as well? And
yes, so right now my plan is to enable defaulting through pod security policy. We've also talked about doing something like storage class where you have a default annotation on one runtime class. This is kind of getting off into the weeds a little bit, but another thing we've talked about is having some sort of pod security policy selector mechanism where I can say a runtime class selector mechanism where I can say I need a runtime class that is sandboxed, or I need a runtime class that supports GPUs or a Windows runtime or whatever, and then match the appropriate runtime class that's in that cluster.
Okay, so if we start rejecting pods based on them requesting features that aren't supported by a particular runtime class, what are we expecting pod authors to do in response to that? Are we expecting them to start like targeting by name particular runtime classes, like well-known runtime classes, or it's unclear to me like how this interacts with what we want pod authors to do. Either pod authors kind of in the abstract, like I'm going to write a pod spec for my thing and expect it to be able to run against most clusters, or pod authors for a particular cluster, like in my environment, I have these named runtime classes and I target them specifically. Like,
Can I ask a question too along those lines before you answer, Tim? So is Windows going to always add a runtime class? Because we've done a lot of prep work talking about Windows nodes versus Linux nodes. Mm-hmm. And I'm of the opinion, based on what I've seen, that it will be impossible to write a pod spec that works on both, and we shouldn't even try. We should have two separate pod specs, one for Windows, one for Linux, just because the moment you need something different, the image isn't enough control to allow you to do it, and defaulting isn't enough. You're going to need to make an opinion. So like some defaulting helps, but like it was very much like on Windows I had expected to have two almost always.
Yeah, so I agree. And that has come up of like the Windows versus Linux decision might be fundamental enough that like it should just be first class within the pod and not
Incidentally, I love that it's 2019 and we're actually having a serious discussion about whether Linux versus Windows are close enough that we can ignore the differences. Tim, I'm going to put that down in the little awesome quotes I heard today.
Yeah, even if we had totally separate pod specs, there might be an argument for using some of the other features that we're adding to Runtime Class to kind of define that Windows versus Linux support. So scheduling and pod overhead in particular will make sense there. And then maybe like Windows versus Linux becomes a feature that Runtime Class supports. And just kind of circling back to the defaulting discussion, it's an interesting point that there is this overlap between supported features and defaulting the runtime class, where it might be nice to be able to say, just here's the pod spec, give me a runtime class that works for it. And in order to do that, we have to know which features are supported by which runtimes.
The runtime class selection bit is interesting. Yeah.
Okay, well, I didn't actually expect like a concrete design to come out of this discussion. I just kind of wanted to start floating some of these ideas.
Is SIG Node where most of this discussion is happening? I mean, a lot of the feature matching and like architecture targeting seems focused there.
Yeah, so every runtime class discussion is going through SIG Node, but I wanted to raise this in particular here because of the overlaps with policy. Yeah. Or you can just ping me directly if you have questions about it.
Could you link the KEPs that are open?
Yep, will do.
Awesome.
All right, Jordan, I think you're up.
Okay, this is mostly just an FYI. One of the things I'm pushing on this year is trying to get APIs that have been in beta forever, making progress towards V1. And so the CSR API is part of the kubelet bootstrap. kubeatom uses it. Several tools are building on top of it, and it has languished in beta. There's a couple issues open that are kind of listing some of the things that we see as shortcomings or things that we would, are maybe gaps to some of the ways we want to use it. But I would like to take a hard look at which of those things are actually required for a V1 and which of those things could be new features to enable additional use cases that we tackle in a V2 stream. So that is the thing that I'm going to be looking at for 1.15 for SIG Auth. So I wanted to throw that out there. People who are interested in following along, I'll copy the SIG mailing list when I open the KEP, but people who are interested can throw their names on there or reach out to me, and I'll be working on that over the next week. So it's just an FYI.
All right, thanks for working on that. So we have about 20 minutes left to look through our issue triage. So first up, unprioritized and unassigned issues. This is sort of a new thing we're doing in this meeting. Did we have a kind of a particular goal for this section?
I thought that things that aren't prioritized and aren't assigned should at least be assigned. And a good first step would probably be the people on the sub-project that would fall under. Just to, yeah, take a look, assign an initial priority, and then once we have things kind of sorted by priority, we can go through and triage.
Let's see. Sorry, so are you suggesting that we agree on priorities for these issues now and then assign after, or assign first?
I am fine with either. I think getting everything that is open should have a priority and somebody assigned. And so whatever path we take to get there is fine. We could also close things if there's agreement that they don't make sense. So those are our three options.
Okay, well, I guess we'll just start at the top of the list and see how far we get.
Sure.
So support for pluggable secret storage.
That is probably Alex, he or Clayton. I think they're the ones on the encryption at rest secrets and are closest to that.
All right.
Immutable. Yeah.
Well, we already answered this question pretty definitively, that we want extensions to happen outside. Yeah.
It's possible. I would be ecstatic for you to find that and paste a link and then close this.
So much work, Jordan.
This is me delegating. Isn't it great?
It's pretty impressive. You're doing an amazing job.
All right, configurable projected volume token rotation period.
That sounds like Mike.
Sorry, whoever's talking, I can't hear you.
And if other people want to jump in, open the list, and start grabbing things that make sense for them, we can parallelize this and make this go faster. Mostly what we want this meeting to be is like a forcing function to make sure we look at our issues. If we actually look at our issues in between meetings, this can be very quick. So
yep.
Plug for the next time.
Support multiple OIDC client IDs. Anyone want to claim this? Or should I assign Mike, since he just left the room?
You can put Mike and I on there.
Do we want to do anything special with stale issues? Maybe not. All right, add support for EFS TLS encryption via the AWS EFS mount helper. I will be honest, I do not know what this means.
This looks like storage, not off. Yeah, that's storage.
Okay. I'm going to assign this back to Mike.
Clayton, did you see that one as well? With the image pull on service account token?
I did not see that. That's just what we were talking about yesterday.
See, it's good that we have these talks.
It is.
Wait, are you sure you just
You didn't forget because it was so long ago that we talked about this?
No, that happens too.
Oh, you got tagged in the description.
Yeah, I'm pretty sure Mike and I talked about this, and then I'm just now remembering.
There was a question in the chat about how people can jump into helping with these. If you're brand new to the area, not all of these are what I would describe as friendly to being like a first issue. If you want to kind of follow along with the design or weigh in on the design, subscribing to open issues and kind of making a comment saying I'd be interested in giving feedback on a design for this could be good. One of the goals for assigning these to individual people is to give people who are interested points of contact so that you actually have a person to reach out to instead of like commenting into a void on an unassigned issue.
Yeah.
Gotcha. Makes sense.
Jordan, would you like to assign this to someone?
Give that to me, and that will probably fold into the V1 cap I'm working on.
Okay, cool. Look at us go.
Stefan commented on this and said he wanted it. David, you want to take this, or Stefan?
Sorry, I'm looking at that. Aggregated cluster role for getting namespaces. Yeah.
Something that people who want to give access to things needed for
aggregated API servers.
Aggregated API servers
could to like dynamic audit stuff. Yes, I will take that.
The question on that.
And do I have to write a caption?
This is a new role in the default RBAC policy. So yeah. I would say no.
Okay. I would say no too. Just want to make sure.
Yeah, no, the title will make it aggregated. I don't understand why.
Jordan, should this go to you as well?
Yeah.
Oh, this is a hotly debated thing.
I don't know how hotly debated it is. It seems like everyone agrees it shouldn't until we have profiles. I think we should close this and reference profiles discussion. I will find something to link this to and then close it.
Okay, thanks. Should I assign you or just?
Sure.
Exec-based auth client auth provider to non-Golang clients.
Oh, this is an exec as the key feature. This is a shell. Okay, I don't care. Sorry. I had a momentary panic attack about the exec protocol.
But like, why do we have to do this?
This is the command line shellout, right?
Yeah, so keep config and say, I want to get my credentials from invoke command here.
It looks like this is just a cover issue for sorry, go ahead. Respective clients.
I mean, so API Machinery is managing the client implementations.
There was, Mike and I had talked a little bit about this for bootstrapping, which is bootstrapping might want to do the same thing, which is exec to get bootstrap credentials so that you could use hardware or a system infrastructure integrated Oracle to get your Bootstrap credentials for kubelets. This is not related to that, but there is something that got lost, and I don't know where he was on that.
I thought Andrew got that working, actually.
Did he? Okay.
You don't use it as a Bootstrap thing. You give the kubelet a kubeconfig that with an exec, and it goes and gets it.
Oh, well, that's amazing.
Yeah.
Um,
2 years of work issue. Who is the owner on this? Greg, you?
on the scheduling policy?
Yeah.
Yassine is the one who is authoring the KEP. But there's kind of a bigger question here about in-tree policies that has sort of been delaying this for a while.
Is that kicking all in-tree policy out?
So it's kind of around whether we should kick in-tree config validation style policies out. So I think when you need deeper integration into other components outside of admission, then it starts to make more sense to have the policy be in-tree, and that's actually the direction that scheduling policy is going in. So rather than trying to have like super expressive policy language that covers the like logic of node affinities and things like that, like what if you just say, here's some additional constraints, scheduling constraints you place on a pod.
Yeah, I mean, we definitely had that in the existing admission tools for a long time in tree, right? Okay.
Yeah.
Because like we kicked pod preset out, and we never kicked pod security policy out, but arguably it could have made faster progress if it had been moved to someplace a little bit more able to iterate. So I didn't know if that was a general pattern that we wanted to discuss.
I think certainly for new policies that the default should be out of tree, unless there's a strong argument for putting it in tree. For pod security policy specifically, I think that's a good discussion topic that maybe we should add to a future agenda.
Yeah. Definitely.
All right. Next three. This looks like policy on finalizers.
This one was more about creating a sub-resource, wasn't it, really?
The mechanism wasn't determined yet. It was more just a requirement to be able to depend on these not being removed by random people or added by random people.
Do you want to suggest an owner for this?
Question is, who will care about this enough to actually do something about it? I think David and I, this kind of splits SIG Auth and API machinery. I don't know, put David and I on there and maybe we'll match each other to do it.
Clayton does not want to talk about this.
Yeah.
As much as I actually do, I feel I do agree, but David and Jordan are both capable of expressing all of my strongest opinions.
Every time something in tree is like, yep, we'll use finalizers to, protect deletion of persistent volume data. I'm like, haha, but anyone can just remove them if they want. Yeah.
and yet you sometimes say, man, I'm so glad I can remove this.
Yeah, no system administrator ever has been angry about
I'm
being.
not proposing we prevent a cluster admin from removing them. Yeah.
This should really be SIG node. Remember this issue. I'm trying to page it in.
Dynamic. Well, there are a couple aspects. One is a dynamic authorization webhook, which I'm not in favor of. The other half is using the same service endpoint resolution for the host that an authorization webhook points to, so you can self-host them.
Uh-huh.
It's funny, I read this title and I'm like, all extension mechanisms we have developed are self-hosting and hostile. All of them. There's not a single one that's not hostile right now. And my meta question here would be, should we, like as a SIG goal, have making self-hosting possible? Because I feel like for a lot of these, like, we've kind of danced around it with Knative. Like as Knative gets better, there's a lot of like webhook style interactions that should be easy on the cluster. And we've always said, like, we'd really love it if it's so easy to extend a cluster that you can just, spin up a service. The reality is somewhere in between. Is it just a long-term thing or is it a short-term thing for us?
How about if you give that to Daniel and I will go fight him about it.
Obviously, this is a super high priority for us.
Yeah. I think authorization in general is hostile. It just says no to everybody.
Yeah.
All right, it's time. Okay.
Yeah, we made good progress.
And
yeah, we can try and finish up the others later.
Feel free to follow those queries and grab things that are in your wheelhouse if you are one of the people who work on the sub-projects. And we'll try to have those lists empty by next meeting.
All right. Thanks, everyone. Have a good rest of your week.